Chapter 1, this chapter is about the introduction to computer networks and data communications. This is the first page. The objective of this chapter is, after reading this chapter, you should be able to define the basic terminology of computer networks, recognize the individual components of the big picture of computer networks, recognize the common examples of computer networks, define the term convergence, and describe how it applies to computer network convergence. Cite the reason for using cite the reasons for using a network architecture and explain how they apply to current network system. List the layers of the TCP/IP protocols suite and describe the duties of each layer. List the layers of the OSI model and describe the duties of each layer. Compare the TCP/IP protocol suite and OSI model and list their differences and similarities. TCP/IP protocol suite and OSI model. So if we go next, this is the introduction. The language of computer networks. Over the years, numerous terms and definitions relating to computer networks and data communications have emerged to gain insight into the many subfields of study and to become familiar with the emphasis of this textbook. Let's examine the more common terms and their definitions. A computer network, and this is the definition. What is the term wireless? What's personal area network, PAN? What is local area network? What is campus area network, CAN? What is a metropolitan area network, MAN? What is wide area network, WAN? Here's the definition of each single one. And what is the cloud? What is the cloud? A very common expression that we hear today is something like, we should store the data on the cloud. The application is in the cloud. The key concept here is cloud and the way we now use it. Similar words or phrases that are commonly used today are network cloud or cloud computing. Very often, the cloud is simply the internet. When a company places data or applications on some website on the internet and allows people to access them, we often say the application we are using is cloud-based. Cloud. And major corporations that have cloud solutions are Amazon, Apple, and Microsoft and Google, and much more. Those are the US companies because the author is from the United States of America. So if you read from a book from a different author belong to a different country, the examples will be different. The study of computer network, and here we have the term data communications and the term interfacing and the term multiplexing and the term compression, compressing the files so they get compressed. It's to reduce the storage space, to reduce the transmission bandwidth, and to add a protection because it's like encryption. Upon a time, a voice network. Now we have a term voice network and we have a voice data network. And we have the term convergence. The Emerging voice and data networks is one example of the term convergence, an important topic that will be presented later in this chapter and further developed in subsequent chapters. So the term convergence is important. Computer security, and now we have is a growing concern of both professional computer support personnel and home computer users with internet connections. Network management is the design, installation, and support of the network and its hardware and software. Chapter 13 discusses many of the basic concepts necessary to support properly the design and improvement of network hardware and software, as well as the more common management techniques used to support a network. The big picture of networks. Now we have workstations, we have servers, switches, and routers. The switches are the collection point for wires and that interconnect the workstations. Routers are the connecting devices between local area networks and wide area networks, such as the internet. And this figure is the first figure in the whole book. It shows the WAN, the LAN, and the routers and modems and whatever, workstations, servers. And here is the base station for microwave tower, which is used in the mobile communication or in the wireless bridges. An overall view of the interconnection between different types of networks. Nodes are the computing devices that allow workstations to connect to the network and that make the decision about where to route a piece of data. Nodes. And we have subnetworks. Sometimes they call them subnets, which consist of the nodes and transmission lines collected into a cohesive unit. And if we keep scrolling, we'll see the next section, common examples of communication networks. And here is another figure, laptop computer with wireless connection, desktop computer, the cell phone, and the desktop computer on the internet. And we have something called client-server system, desktop computer, or simply microcomputer at work, showing the connection between the user and the company's local area network, like this blue cable here, and that goes to the switches. If we keep scrolling, we'll see another figure that shows a microcomputer sending data over DSL line. Now, no one is using DSL lines anymore to an internet provider and into their network. So this is just a historic use of modems. Now, I don't think anyone is using modems anymore. A laptop computer and wireless connection, and we have here the term protocols. And the communication protocol is a set of rules used by communication devices for wireless local area networks and wired local area networks. So we have the communication protocols. One of the very famous communication protocol is the TCP/IP. We keep scrolling because we are skimming a book. We are not really reading every single word. We're just looking, just skimming really quick. And the two local area networks connected by a switch. We have this network on the top, LAN A, and then another network at the bottom, which is LAN B, and each one is connected with the hub or switch, and we have a switch that connects the two networks. Cell phone systems, mobile phones, mobile communication. We also have a smartphone communicating to the base station, wireless transmission tower, they call it base station, and a land-based telephone line, which is not really used in many countries right now. Everything became wireless, but the conversion between these two used to occur over decades, but now mostly it's just a wireless thing. Other common network systems. An automobile moves down an assembly line and triggers a sensor. This is a communication system, network system. So it can be dedicated and not commonly used in the assembly lines, in the pipelines. And here, sensors writing to LAN, and a computer terminal, a device that essentially a keyboard and a screen with no large hard drives or no gigabytes of memory and little of any processing power. This is called terminal. Using terminal or thin client workstation, now they call it thin client workstation, to perform a text-based input transaction to do simple tasks that doesn't really require any processing power. Motor vehicle license branch, they use terminal cable connecting to mainframe, the MVD. And if we keep going, an example of TV company using a satellite system to broadcast television services into homes and businesses. So this is the satellite, it's a computer network or communication network. And these are receivers. This is a transmitter, and this is these are all the receivers, satellite dishes. All right. Convergence. A dictionary might define convergence as the process of coming together toward a single point with respect to computer networks and communication systems. This definition is fairly relevant. Over the year, the communication industry has seen and continues to see different network applications and technologies that support them converge into a single technology capable of supporting various applications. In particular, we can define three different types of convergence technologies, three different types of convergence: technological convergence, protocol convergence, and industrial convergence. All right, coming together. So we have three different types: technological, protocol, and industrial. And each one is explained in this text. Network architectures. Network architectures. And here the models, and how we have two main models. One is called the Open System Interconnection Model, OSI model, and the TCP/IP model, or TCP/IP protocol suite. Consider that a typical network within a business contains the following components that must interact in various ways: wires, printed circuit boards, wiring connectors and jacks, computers, centrally located wiring concentrators, disk and tape drives, computer applications such as word processors, email programs, and accounting, marketing, electronic e-commerce software, computer programs that support the transfer of data, check for errors when data is transferred allow access to the network and protect user transactions from unauthorized viewing. This large number of network components and their possible interactions inspires two questions. First, how do all of these pieces work together in harmony? Work together harmoniously. And how you do not want two pieces performing the same function or no piece performing a necessarily function. So they need to work in harmony. The second question, does the choice of one piece depends on the choice of another piece? That's the second question. Of course, the answer is in the model. And TCP/IP suite. And here in the TCP/IP suite, the TCP/IP protocol suite was created by a group of computer scientists in order to support a new type, ARPANET, being installed across the United States in the 60s and 70s. The goal was to create an open architecture that would allow virtually all networks to intercommunicate. The design was based on a number of layers in which the user would connect at the uppermost layer and would be isolated from the details of the electrical signals found in the lower layer. The number of layers in the TCP/IP suite is not static. In fact, some books present the TCP/IP suite as 4-layer, others present as 5 layers. Even then, different sources use different names for each layer. For this book, we'll have 5 layers, as shown in figure 110. The layer names is the application layer, the transport layer, the network layer, the network access layer, and the physical layer. And this is the figure 110. Network worker perform their job duties at each layer in the model. So like each layer has its own task to do. The higher layer is the application, then the transport, then the network, then the network access, then the physical. The TCP/IP application layer includes several frequently used applications. We have frequently used applications and that uses TCP/IP. One of them is the HTTP, and the other one is the SMTP. The SMTP is for the email, simple mail transfer, to allow users to send and receive email. The HTTP allows web browsers and servers to send and receive www pages, or they call it HTML pages. FTP to transfer files. Telnet to allow a remote user to log in another computer system. Telnet to telnet that computer, like to control it remotely, to log into that computer, to that device, Cisco device or something using Telnet. SNMP, Simple Network Management Protocol, allows numerous elements within a computer network to be managed from a single point. SNMP, it's a management protocol. And if we keep going, we'll see different terms like transport layer, network layer, internet protocol, network access layer. What is the frame? The network access layer prepares a data packet called a frame for transmission from the user workstation to a router sitting between the local area network and the internet. Okay. And we have the physical layer here. The OSI model, Open System Interconnected Model. The Open System Interconnect model has 7 layers, and they are shown here on the left-hand side. The TCP/IP layer shows here on the right-hand side. And the names is the application, presentation, session, transport, network, data link, and physical layer. This is called the OSI layer, OSI model, OSI layers. Token management, a service that controls the user's computer talks during the current session by passing software token back and forth. Additionally, the session layer establishes synchronous points. And here is the explanation. And we have the transport layer, and we have the network layer. And now we don't have the network access. We have something called data link layer. Okay, similar to the TCP/IP's network access layer. And the physical layer is the same for physical handling. That handles the transmission of bits over the communication channels. The layer is essentially identical to the physical layer of the TCP/IP protocol. Logical and physical connections. Sender and receiver communicates using TCP/IP protocol. Logical connections, and only the bottom one, which is the physical, is the really physical connection. And we have the logical connection here and the physical connection term here. And if we keep scrolling, flow of data through the layer of bureaucracy. Okay. So here it goes like this. School of Art and Science to the School of Business goes through that, and similar way. Bureaucracy. All right. And the details, the Internet Request for Comment, RFC. And here's the details. And what's the name of the organization that creates and approves network standards? It's called the ISO, International Organization for Standardization. This is very important, which is a multinational group composed of volunteers from the standard-making committees of various governments throughout the world. ISO is involved in developing standards in the field of information technology and created the OSI model, Open System Interconnection model, for network architecture. Other standards making organizations include the NC, American National Standard Institute, the ITU, International Telecommunication Union, Telecommunication Standardization Sector, ITU-T, the IEEE, Institute of Electrical and Electronics Engineers, IEEE, EIA. EIA is a non-profit organization devoted for the standardization of electronics products. All right, so we have the ISO, we have the ANSI, we have the ITU, we have the IEEE, and we have the EIA. All right, and we keep going. So before that, let's go through this figure. Level of progression, and RFC moves forward becoming a standard. So it comes from a draft, proposed standards, draft standard, internet standard, and historic. So defeated standard becomes historic, defeated standard becomes historic, just like that. And it became standard here. All right. TCP/IP protocol suite in action. User web browser application, get the web page, transport layer, TCP header, get the web page, network layer, IP header, TCP header, get the web page, network access layer, LAN header, IP header, TCP header, get the web page, LAN trailer. Now we have a trailer. All right. And local area network, local routers, IP header, TCP header, and get web page. The path of a web page request as it flows from browser to an internet web server and back. All right, we'll keep going. The summary. Many services and products that we use every day employ computer network and data communication in a way or another. Telephone systems, banking system, cable TV, audio and video system, traffic control system, cell phone, and a few other examples. The field of data communication and computer networks also includes data networks, voice networks, wireless networks, local area networks, campus area networks, metropolitan area networks, wide area networks, personal area networks. And the common example of computer networks, here are they. And the key concept in networking in these days is convergence. Convergence, the phenomena in which network applications and technologies that support the converge into a single technology, that it is capable or merged, like converged, like merged, that's capable of supporting various applications. Network architecture, TCP protocol, TCP/IP protocol suite, the ISO OSI model, 7 layers, and the key terms and review questions. If you read the chapter really good, you should be able to answer all these review questions. What's the relationship between subnet network and a node? List the 5 layers of TCP/IP protocol suite. What is the definition of telecommunications? What is the difference between logical connection and physical connection? What kind of applications might use a desktop computer to internet network? How does convergence apply to communications industry? What language must a home computer talk to other to interface with internet? All right, and much more review questions. The exercises, these are: create a list of actions you perform in an average day that use data communications and computer networks. This is an exercise. If you could design your own home, what kind of labor-saving computer network or data communications devices would you incorporate? Using a laptop computer with a wireless connection to a company's local area network, you download a web page from the internet. List all the different different networks possibly involved in this operation. List all of them. You are sitting at the local coffee shop enjoying your favorite latte. You pull out your laptop and, using the wireless network available in the coffee shop, access your email. You open your email from the laptop through Wi-Fi. List all the different network networks possibly involved in this operation? Okay, and much more exercises. All these are exercises. List the TCP/IP protocol suite layer that performs each of the following functions: data compression, multiplexing, routing, definition of single electrical characteristics, email, error detection, end-to-end flow control. These are questions, exercises. You are watching a TV show, and this is another exercise. So all these are exercises. Thinking out of the box, or thinking outside the box. You have been asked to create a new network architecture model. Will it be layered, or will its component take some other form? Are you going to use layers or some other form? Show your model's layers or its new form and describe the functions performed by each of its components. Take an example from your network, from your work or school, in which a person requests a service, then diagram that request. Does the request pass through any layers before it reaches to the intended recipient? Do logical connection as well as physical connection exist, just like the OSI model or the TCP/IP suite model? This chapter listed several different types of example networks. Do any other networks exist in real world that are not listed in this chapter? If so, what are they? Several different types of example networks. Do you have more of these? Maybe, maybe not. Describe a real-life situation that uses at least 3 of the networks described in this chapter. Hands-on projects. And here we have a hands-on project, 6 hands-on projects.